Our next topic is coordinate geometry. Under this topic, candidates should be able to 1. Determine the midpoint and gradient of line segments. First point is midpoint. Midpoint. And the second one is gradient. Then point 2, distances between 2 points. Then identify conditions for parallelism and perpendicularity. Find the equation of a line, 2 points from. So these are the summary of what the candidates ought to know as far as this topic is concerned. So let's take them one by one. Midpoint. Midpoints, if you're having a point AB, then this point, by the time you make an arc, then you mark this and come to this side and mark this. So this point is definitely a midpoint between A and what? B. So this midpoint has a formula. Considering coordinates x, x1, as a p, x1, y1, and q, x2, y2. So midpoint of PQ will now be half of x1 plus x2, comma, half y1 plus y2. That's the formula for calculating the midpoint. Then gradient. Gradient is also known as what? Slope. It's also known as what? Slope. And it is usually change in y over change in x. Change in y over change in x, which means y2 minus y1 over x2 minus x1. So that's the gradient of one. Then the next one is distances between 2 points. Distances between 2 points. So if you have to calculate distances between 2 points, let's say you have a point here, which is maybe x comma y, and you have another one here, q. This one is x1 comma y1, and this is x2 comma y2. Then you now want to determine this distance. Let's say this is a point to this point. So you have to determine distance between P and Q, or PQ. Then you have, the formula is d squared, which is equals to, we have x2 minus x1 all squared plus y2 minus y1 all squared. Then the distance will now be square root of x2 minus x1 all squared plus y2 minus y1 all squared. That's the formula for calculating the distance, and mostly it is always expressed in square units. Take note of that. Then the conditions for parallelism and perpendicularity. So in this situation, from this equation, from tan alpha, which is usually absolute m2 plus m1 over 1 minus m1 m2. m2 minus m1. So in this situation, we have a scenario like this. So if you have a scenario like this, then if the angles between 2 points, if the angle between 2 points is 0, definitely that means you have tan, then that means our alpha will be 0, then we have tan 0, which is is 0. So in that situation, then we have, going to this formula, we have 0 equals to m2 minus m1 over 1 minus m1, m2. So I'm trying to work on all this is condition for what? Parallelism. Take note of that. So in that situation, so we cross multiply, that means you have m2 minus m1 equals to what? 0. Then m2 equals to m1. So this is the condition for what? Parallelism. Before two lines can be said to be parallel, then the gradients of the two must be equal to what? The gradient of the one. So that means because m is the gradient, so m2 must be equal to what? m1, provided that the angles between them, because when two lines are parallel, that means they can never meet. So in that situation, the angle between them is 0. Then the second condition, that is for perpendicularity. Before two lines can be perpendicular, that means the angle between them must be what? 90 degrees. That's our basic mathematics. So the angle between them must be what? This one is gradient of m1 and m2. The angle between them must be what? 90 degrees. So that means if the angles between the 2 points or lines, if the angle between 2 points or line is 90 degrees, that means our alpha is what? 90 degrees. And tan alpha, that's tan 90 degrees, is what? Infinity. So what it means is that what condition will make these two lines to be what? Perpendicular. That means the denominator 1 minus m1, m2 must be equal to what? 0. Because that is what will make this to be what? Undefined. Because tan 90 equals to infinity, that means it's what? It's undefined. So what will make it to be undefined is when we have m2 minus, okay, here we have plus. So the what's it called? The initial relationship is that tan alpha equals to m2 minus m1 over 1 plus m1 m2. So what I've been working with is what? m1 plus m1 m2. That's 1 plus m1 m2. So at this point we have m1 plus m2 and m1 plus m1 m2. That is what we're going to have here. So at this point then we have m1 m2 equals to what? Minus 1. So what it means is that for two lines to be perpendicular, the product of their gradients must be equals to what? Minus 1. Take note, this is a condition for what? Perpendicularity. Perpendicularity means for two lines to be perpendicular, the product of their gradients must be equals to minus 1. For two lines to be parallel, m1 must be equals to what? m2. So those are the two conditions for parallelism and what? Perpendicularity. Then the equation of line, we have one point form. 1 point. If you are given 1 point, the grade of the line, if you are given 1 point, which let's denote by, because the equation of the line is y equals to mx plus c anywhere in the world. Y equals to mx plus c, where m is the gradient. Where m is the gradient. And c is the what? Intercept. So in this situation, for 1 point, we have x comma y. Then we have x1 comma y1. So for 1 point, we are going to have y minus y1 over x minus x1 equals to our gradient. Take note of this for 1 point. So this is the gradient of 1 point form. For 1 point form, 1-point form which has been established earlier. So it will be gradient equals to y minus y1 over x minus x1. Then for 2-point form, 2 points. So we are going to have y gradient will be y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. So for 2-point form, that means we have x1, y1. Then we have x2, y2. So the gradient of that is what we have here. Then I said earlier that y equals to mx plus c. N is the gradient. YC is the what? Intercept. And we have 2 intercepts. We have intercept, we have x-intercept. We have x-intercept, that's when our y is 0. Then we have our y-intercept. That's when x is 0. Take note of that fact. There are 15 UTME questions designed for this topic as shown in figure 1.6a below on the board. Then this topic is what?